Hello everyone, I am delighted to share with you our work which deals with site selection for implementing thermal desalination using membrane technologies in Morocco. This work was conducted as part of a project that involves the development of a pilot unit for simultaneous electricity and water production using concentrated solar power and brackish water for osmosis. The outlines of the presentation are as follows. First, some interesting brackish water aquifers have been identified. Then the analytic hierarchy process method is applied to compare the brackish water aquifers according to a set of 6 criteria. As a result, the considered brackish water aquifers were classified according to their importance. So, Morocco has significant brackish water potential distributed across its territory with variable water holdup and salinity. This amount of brackish water could be exploited to produce fresh water by exploiting the abundant solar irradiance through membrane thermal desalination, especially in rural arid regions. In this work, 5 brackish water aquifers have been identified as reported in this table. This table also summarizes the characteristics related to each aquifer itself and those related to the weather conditions of the region where the aquifer is located, which include rainfall and solar irradiance. The analytic hierarchy process method has been adopted to compare the previously mentioned aquifers, so water holdup, total dissolved salt or salinity, water table depth, hydraulic conductivity, rainfall, and solar irradiance were considered as decision criteria, so as input to the analytic hierarchy process. The output of this process is to classify the aquifers according to their importance with respect to the final decision, which is to identify the most suitable site for implementing solar thermal desalination plants. The analytic hierarchy process method consists in prioritizing the importance of each criterion over another with respect to the final objective, which is identifying the aquifer that holds the greatest amount of brackish water, has moderated salinity, minimum water table depth, and maximum hydraulic conductivity to ensure good recharging rate, and also the region should have highest rainfall and solar irradiance also. To compare criteria to each other, we have to establish the pairwise comparison matrix given in this table. To form this matrix, we often ask the question how a decision criterion is important over another regarding the objective of the benchmark study. In our case, the water holdup is considered to be 2 times more important than rainfall, 3 times than salinity, 6 times than water table depth, 5 times more important than hydraulic conductivity, and 3 times than solar irradiance. We follow the same approach to compare the other criterion to each other, namely rainfall, salinity, depth, and hydraulic conductivity, and so on. So, during the pairwise comparison matrix establishment, inconsistencies arise due to the randomness associated with criteria weights assignment process, in which we give an estimated weight to a criterion according to its importance over another criterion. Therefore, we have to test its consistency by calculating the corresponding consistency ratio that can be evaluated using equation 1 that involves the consistency index that should be evaluated through equation 2. The parameter n represents the number of criteria, and alpha max is a parameter that should be carefully estimated. The parameter lambda max is evaluated through different steps. The first one consists in normalizing the pairwise comparison matrix using equation 3, where AAJ represents the original criteria value for each aquifer, and CWI the estimated criteria weights evaluated through equation 4. The criteria weights values are further used to determine the weighted sum values of each criteria via equation 5. Next to this step, the parameter lambda max can be derived as the maximum value of the ratio between weighted sum values and the corresponding estimated criteria weights. Following this approach, the normalized matrix of the estimated criteria values is established as given in this table. So, To classify the considered aquifers according to their importance with regard to the entire set of criteria, an importance rate indicator is established. Based on this indicator, the Tafilalet aquifer is considered to be the most interesting, followed by Errachidia and Warzazat. These aquifers are demonstrated to be suitable due to their important brackish water holdup and moderated salinity and water table depth. Additionally, the soil irradiance of the region where they are located is very promising for thermal desalination plants. To conclude, we can say that interesting brackish water potential has been identified in Morocco associated to abundant solar irradiance could be important to promote membrane desalination using solar thermal energy in Morocco. The 5 brackish water aquifers identified have been classified to give decision makers a good idea about where to implement the thermal desalination plant using membrane technology and solar thermal power. So thank you for your attention.